Have you ever wondered how network devices communicate and manage data? Today, we dive into the world of SNMP. Imagine a bustling city with a myriad of roads, bridges, and intersections. Each vehicle on those roads represents data, and the entire city infrastructure is like a network. To ensure smooth traffic flow, there needs to be an efficient system in place, and that's where SNMP comes into play. SNMP, or Simple Network Management Protocol, is an Internet Standard Protocol, a set of rules, if you will, that governs the communication and management of data among network devices. These devices could be anything from routers, switches, firewalls, load balancers, servers, to CCTV cameras and wireless devices. Think of SNMP as the traffic police of this city of data. It ensures that the data or vehicles reach their destination without any hiccups. It keeps an eye on the traffic and maintains an orderly flow. Without SNMP, managing and monitoring network devices would be like navigating a city without any traffic rules. Things could get chaotic pretty quickly. It's like trying to have a conversation in a room full of people talking at the same time. Without some sort of order, your message could get lost in the noise. SNMP brings that order to the network devices. It allows them to talk to each other in an organized manner, making sure that the necessary data is collected, sent, and received as needed. So, in a nutshell, SNMP is the unsung hero of network management. It keeps the data flowing smoothly, ensuring that your internet works when you want to stream your favorite show, your email lands in the right inbox, and your online game doesn't lag at the worst possible moment. Now that we know what SNMP is and its importance, let's delve deeper into its components. The SNMP ecosystem is made up of several key components, each playing a vital role. To start, we have the SNMP Manager, also known as the Network Management Station. It's essentially the control center of the SNMP system. The manager communicates with all the other components, retrieves data, sets variables, and acknowledges events. It's like the conductor of an orchestra, coordinating all the different parts to make sure they're working in harmony. Next, we have the managed devices. These are the network devices that the SNMP manager is monitoring and managing. They could be anything from routers, switches, servers, to CCTV cameras. Each of these devices has an SNMP agent implemented. The agent is a piece of software that resides in the managed device and is responsible for collecting the device's operational information and relaying it back to the SNMP manager. Last, but certainly not least, we have the SNMP Management Information Base, or MIB for short, and the Object Identifiers, known as OIDs. The MIB is like a database that contains information about the managed devices. Each piece of information is assigned an OID, a unique identifier that the SNMP manager uses to request or manipulate data. Think of the MIB as a library and the OIDs as the unique call numbers for each book. To wrap up, the SNMP manager is the command center, the managed devices are the players, the SNMP agents are the go-betweens, and the MIB and OIDs are the information library. Understanding these components is crucial to grasp how SNMP works. Now that we've covered the individual parts, we're ready to dive into how they all work together. Stay tuned for the next scene where we'll explore the inner workings of the SNMP. SNMP is not just a protocol, it's a mechanism that enables efficient network management. Let's dive into how exactly SNMP works. Picture a network full of devices, routers, switches, servers, and even CCTV cameras. Each of these devices is like an island, and SNMP is the ferry that allows us to reach these islands. But for the ferry to dock, there needs to be a port. In the world of SNMP, these ports are called SNMP agents. So the first step in how SNMP works is that it sends SNMP GET requests to devices that have SNMP agents implemented. Think of it as the ferry sending out a call to the island, asking if it can dock. Once the SNMP agent receives a GET request, it responds with the requested information. This could be anything from the device's uptime to the amount of network traffic it's handling. The SNMP manager then retrieves this data, effectively docking at the island and collecting what it needs. But SNMP isn't just about retrieving data. It also sets variables on the managed devices. This is akin to the ferry delivering what the island needs, whether it's a new configuration setting or a software update. Furthermore, SNMP acknowledges events. This means the protocol is also responsible for recognizing when something significant happens on the network, such as a device going offline or reaching its capacity. It's like the ferryman noticing a change in the island's landscape or population. This entire process is a continuous loop, with the SNMP manager constantly communicating with the SNMP agents, retrieving data, setting variables, and acknowledging events. This ensures that the network is always monitored and managed efficiently. So, to sum up, SNMP works by sending out calls to devices on a network, docking at these devices to retrieve data and deliver updates, and keeping an eye out for any significant changes. It's a tireless ferryman, ensuring the smooth running of our network islands. With this understanding, now we can explore the different versions of SNMP. SNMP has evolved over time, with each version bringing new capabilities. The Simple Network Management Protocol, or SNMP, has three major versions: SNMP v1, SNMP v2c, and SNMP v3. Each of these versions has brought about its own set of features and functionalities to better manage network devices. SNMP v1 is the original version, but it has some limitations, particularly in terms of security. It uses community strings for authentication, which are transmitted in plain text over the network. While SNMP v1 is still widely used, it's generally considered to be less secure than its successors. SNMP v2c, the second version, introduced bulk data transfer capabilities, which improved network performance and efficiency. However, like SNMP v1, SNMP v2c still uses community strings for authentication, leaving it somewhat vulnerable. And then we come to SNMP v3. This is the most secure version of the protocol, as it introduces both encryption and user-based security. With SNMP v3, data integrity, authentication, and privacy are all assured, making it the preferred choice for most modern network management tasks. Now, let's shift gears and talk about SNMP commands. These commands are the tools that enable us to retrieve, manage, modify, and pass data from network devices. The GET command is used to retrieve a single piece of information from a device. The GET_NEXT command, on the other hand, retrieves the next piece of information in the Management Information Base, or MIB. The GET_BULK command is used to retrieve large amounts of data at once, a feature introduced in SNMP v2c. Finally, the SET command is perhaps one of the most powerful commands in SNMP. It allows a network manager to set or change the value of an object in the MIB. This means we can use the SET command to change configurations on a network device, or even to reboot a device remotely. These versions and commands form the backbone of SNMP's functionality. We've covered a lot about SNMP. Let's summarize the key points. Simple Network Management Protocol, or SNMP, is an internet standard protocol. It's the unsung hero behind the scenes, diligently monitoring and managing network devices connected over an IP network. From routers and switches to servers and wireless devices, SNMP facilitates communication, keeping the network functioning smoothly. In the bustling city of our network, the SNMP components play their unique roles. The SNMP manager, like a city mayor, communicates with the agents, retrieves data, sets variables, and acknowledges events. The managed devices, with their implemented SNMP agents, are the city's residents responding to the manager's requests. And the SNMP MIBs, or Management Information Bases, are the city's records containing object identifiers, or OIDs. But how does SNMP work? It's a bit like a game of ping pong. The SNMP manager sends GET requests to the devices with SNMP agents. These agents respond with the requested data, sending it back to the manager. This continuous back and forth ensures the network's health and performance are monitored and managed effectively. SNMP comes in 3 flavors: SNMP v1, SNMP v2c, and SNMP v3. With each version, SNMP evolved, becoming more secure and efficient. SNMP v3, the latest and most secure version, is the recommended choice for most professionals. And let's not forget the SNMP commands: get next, get bulk, and set. They are the language of SNMP, used to retrieve, manage, modify, and pass data from network devices. SNMP's importance in network management cannot be overstated. It's not just a protocol, it's a crucial tool for IT professionals. With it, they can ensure the network's stability, troubleshoot issues, and optimize performance. SNMP is more than a protocol. It's a vital tool in the toolkit of every IT professional. Until next time, keep exploring and keep learning.